Hector program to toggle bits of port P continuously with a time delay of 250 milliseconds. So, in an earlier problem, we had discussed wherein the time is not specified, but there was a delay. Like in this case, it is with some delay. Okay, so you're just assigning a counter and you're changing the counter value. So there is a delay here, but then the delay size is unknown. So suppose the delay size we know and we want to design a particular program for a particular delay. So here the delay is 250 milliseconds. So what we are doing here is toggle the bits of port P1. So we know that the port P1 bits can be toggled by sending 55H and AAH continuously to that particular port. So in between the 55 and AA that is sent to the port, we are going to introduce a delay, and the delay size is 250 milliseconds. So this delay is defined here using void ms delay unsigned integer. So here the name of the delay is ms delay. You can name it as you like, and the delay size will be defined as an unsigned integer. So time mostly it is defined as an unsigned integer, not as character. So here after sending P1 equal to 55H, 55H, the hex value is defined like this 0x, then the value. And here I am introducing the delay. So it's like calling a subroutine which is defined by the name ms delay, which I've declared here, and in brackets the size of the delay is specified. So size of the delay specified here is 250, which is normally taken as 250 second, not 250 millisecond. So I'll have to convert it to 250 millisecond. Again, after sending P1 equal to AAH, I'm calling a delay subroutine again by the same name ms delay 250. So just understand that the P1 here should be in caps, capital letters, and this will continue forever. And how do I make sure that it is continued forever? By giving a while one loop. So while one means this will repeat forever. So how do you write this subroutine, delay subroutine? So that's outside the loop. Here I am writing the delay subroutine. So how? Void ms delay. Again, it is here I have specified it as unsigned integer. Same unsigned integer I am specifying it here. But the difference is that I am specifying the name of the unsigned integer. That is I time. So I time is the unsigned integer attached to this delay. So I time is a variable which is declared as an unsigned integer which will specify the delay size. So here you can see that void ms delay in brackets unsigned integer. Here ms delay 250. So what is 250? 250 is the value assigned to the unsigned integer, which is the delay size. So this 250 is also assigned a variable called itime. So you can say that itime is a variable which is declared as an unsigned integer which has a value of 250. So in both these cases, I am declaring it as unsigned integer only. Here I am defining the variable attached to it, and here I am saying the value assigned to it. Now coming to the subroutine, the unsigned integer, it is I time, and this 250 millisecond, as the question is 250 millisecond, this I am achieving using two variables, two for loops. Why two for loops? Because here I have defined it as 250 milliseconds. Sorry, 250 seconds. So here I don't have an option to say it is milliseconds. So what I'm going to do is I'm going to multiply this 250 seconds with 1 millisecond. So how do I do that? For I equal to 0 to I less than I time. So I time is what? 250. So I will vary from 0 to 250 minus 1. That is I equal to 0 to I less than I time. So 0 to 249. So that will be 250 in total. So I will be incremented for 250 times. Then this will be multiplied by a value equal to 1 millisecond, which I will achieve using this particular for loop. So for j equal to 0, j less than 1275, j plus plus. So this is achieved, this will give you a 1 millisecond delay. So that when multiplied by this 250, in total you will get an approximately 250 millisecond delay. Where? Here and here. So how do we achieve that 1 millisecond delay? So we know that for 8051, if we are taking the case of 8051, normally we say that the clock frequency is 11.059 megahertz. So coming to the time period will be 1 by the frequency, 1 by the clock frequency. That will be approximately 0.09 microseconds. And we know that one machine cycle is equal to 12 T states in the case of 8051. So for one T state, the time is 0.09 microsecond. For the time for one machine cycle, that is equal to 12 T states, will be 12 into 0.09 microsecond, that is 1.08 microsecond. So you have the clock frequency, that is one cycle. Frequency is 11.059 megahertz. So clock time period for one T state, the time period is 0.09 microsecond, and for 12 T states, which is equivalent to one machine cycle, the time is 12 into 0.09 microsecond, that is equal to 1.08 microsecond. And if you want a 1 millisecond delay, what I'll do is I'll multiply this 1.08 microsecond. This I have to convert to millisecond. So how do I convert it to millisecond? By multiplying by I'm doing it with 1275, which is the standard way of doing it. But when you multiply it with 1275, what I get is 1383 microsecond, that is 1.383 millisecond. This I am approximating it as 1 millisecond. Okay, so this 1275 is used in a standard way, and what I get actually is 1.38 microsecond theoretically, which I'll be approximating as 1 millisecond. So this 1 millisecond will be multiplied with the 250 to get the 250 millisecond.